The National Electrical Code, or NEC, addresses the bonding of metal components in electrical systems. Article 250.104 specifies that all exposed and accessible metal raceways, enclosures, frames, fittings, and other conductive materials enclosing electrical conductors or equipment must be effectively bonded to the grounding system. Furthermore, Article 250.112F mandates that embedded to concealed or inaccessible ferrous metal objects within or adjacent to the premises be bonded to the grounding system. The code requires bonding of both exposed and accessible metal components, as well as embedded or inaccessible ferrous metal objects near the premises. Rebar stubs, even if currently not exposed, would need bonding once concrete is poured, according to NEC 250.104A. There are several options available for bonding the rebar stubs. Firstly, extend the rebar stubs. If feasible, extend the rebar stubs far enough out of the concrete to make them accessible for bonding. This allows for the attachment of bonding clips or other suitable bonding methods. Secondly, weld bonding plates. Bonding plates can be welded to the exposed rebar stubs. These plates can be utilized for attaching bonding clips or other bonding methods. Thirdly, use conductive grout. The holes created by the cut-off rebar stubs can be filled with a conductive grout. This grout would establish a pathway for electrical current, effectively bonding the rebar stubs to the surrounding concrete. It is important to consult with the architect, engineer, and electrical inspector to receive specific guidance on bonding requirements for the project. The purpose of bonding is to create a low impedance path for fault current. This ensures that overcurrent protective devices, such as circuit breakers or fuses, will quickly and effectively clear ground fault. Bonding also reduces the risk of electric shock by minimizing voltage differences between metal parts. When a ground fault occurs, current flows through the bonding system back to the source. This high current flow causes the overcurrent protective device to trip, de-energizing the circuit and preventing a dangerous voltage from being present on metal parts. Without proper bonding, a ground fault can result in a sustained voltage on metal parts, posing a significant electric shock hazard. The NEC provides detailed requirements for bonding different types of metal components, including metal water piping systems, metal gas piping systems, and structural metal. These requirements are designed to ensure that all metal parts are effectively bonded together and connected to the grounding system. Bonding methods typically involve the use of bonding jumpers, which are conductors that connect metal parts together. Bonding jumpers must be sized appropriately to carry the available fault current. The size of the bonding jumper is determined by the size of the circuit conductors. The NEC provides tables that specify the minimum size of bonding jumpers for different circuit sizes. In addition to bonding jumpers, other bonding methods include the use of listed bonding connectors and clamps. These connectors and clamps are designed to provide a reliable electrical connection between metal parts. When installing bonding conductors, it is important to ensure that they are protected from physical damage. Bonding conductors should be routed in a manner that minimizes the risk of them being cut, abraded, or otherwise damaged. Bonding conductors should also be securely fastened to the metal parts that they are connecting. The NEC also addresses the bonding of swimming pools. Swimming pools are considered to be particularly hazardous locations due to the presence of water and the potential for electric shock. The NEC requires that all metal parts associated with the swimming pool be bonded together and connected to the grounding system. This includes the pool reinforcing steel, the metal pool shell, metal conduit, metal piping, and metal equipment. The purpose of bonding the swimming pool is to create an equipotential plane around the pool. An equipotential plane is an area where all metal parts are at the same electrical potential. This minimizes the risk of electric shock by preventing voltage differences from developing between metal parts. The NEC also requires the installation of a bonding grid under the pool. The bonding grid is a network of bare copper conductors that are buried in the ground under the pool. The bonding grid is connected to the pool reinforcing steel and other metal parts, providing a low impedance path for fault current. The NEC provides specific requirements for the size and spacing of the bonding grid conductors. In addition to bonding, the NEC also requires the installation of ground fault circuit interrupters, or GFCIs, in swimming pool circuits. GFCIs are designed to detect small ground faults and quickly to energize the circuit. GFCIs provide an additional layer of protection against electric shock. When working with electrical systems, it is important to follow all applicable safety procedures. Always to energize circuits before working on them. Use appropriate personal protective equipment, such as rubber gloves and safety glasses. If you are not qualified to work on electrical systems, hire a licensed electrician. Electrical work can be dangerous, and it is important to take all necessary precautions to prevent accidents. The NEC is a comprehensive set of rules that governs the installation and maintenance of electrical systems. The NEC is updated every 3 years to reflect changes in technology and safety practices. It is important to stay up to date on the latest NEC requirements to ensure that electrical systems are installed and maintained safely. The NEC is enforced by local electrical inspectors. The electrical inspectors will review electrical plans and inspect electrical installations to ensure that they comply with the NEC. The NEC is an essential tool for ensuring electrical safety. By following the NEC requirements, we can help to prevent electrical accidents and protect people from electric shock. Remember to always consult the latest edition of the NEC and local amendments for specific requirements in your area. Electrical codes and standards are continuously evolving to incorporate new technologies, improve safety, and address emerging challenges. Staying informed about these changes is crucial for electrical contractors, engineers, and inspectors. Changes in the NEC can affect the way electrical systems are designed, installed, and maintained. Understanding these changes is essential for ensuring compliance and preventing costly errors. Continuing education courses, industry publications, and professional organizations can provide valuable resources for staying up to date on the latest electrical codes and standards. Engaging with these resources can help electrical professionals enhance their knowledge, skills, and expertise. Conductive grout is a specialized type of grout that contains conductive materials such as carbon or metal particles. These materials allow the grout to conduct electricity, creating a low resistance path between the rebar and the surrounding concrete. Conductive grout can be an effective option for bonding rebar stubs that are difficult to access or weld. The use of conductive grout requires careful consideration of several factors, including the type of grout, the application method, and the environmental conditions. It is important to select a conductive grout that is compatible with the concrete and the rebar materials. The application method should ensure that the grout completely fills the void around the rebar stub, providing good electrical contact. Environmental conditions, such as temperature and humidity, can affect the curing and performance of the conductive grout. Welding bonding plates to the rebar stubs is another option for bonding. Welding provides a strong and reliable electrical connection between the rebar and the bonding plate. The bonding plate can then be used to attach a bonding conductor, which connects the rebar to the grounding system. Welding requires specialized equipment and expertise. It is important to use appropriate welding techniques and materials to ensure a sound weld that will not corrode or weaken over time. The welding process should also be performed in a safe manner, following all applicable safety precautions. Extending the rebar stubs is the most straightforward option for bonding. By extending the rebar stubs out of the concrete, they become easily accessible for bonding. This allows for the use of standard bonding clamps or connectors to attach a bonding conductor. Extending the rebar stubs may not always be feasible depending on the design and construction of the concrete structure. However, if possible, it is the preferred method for bonding. The size of the bonding conductor is determined by the size of the circuit that is being protected. The NEC provides tables that specify the minimum size of the bonding conductor for different circuit sizes. It is important to use the correct size bonding conductor to ensure that it can safely carry the available fault current. The bonding conductor should be made of copper or other conductive material that is approved for use in electrical systems. The bonding conductor should be installed in a manner that protects it from physical damage. The bonding conductor should be securely fastened to the rebar and to the grounding system. The grounding system is a network of conductors that are connected to the earth. The grounding system provides a low impedance path for fault current to return to the source. The grounding system is essential for electrical safety. The grounding system should be properly installed and maintained. The grounding system should be inspected regularly to ensure that it is in good condition. The grounding system should be tested periodically to ensure that it is functioning properly. When working with electrical systems, it is important to follow all applicable safety procedures. Always to energize circuits before working on them. Use appropriate personal protective equipment, such as rubber gloves and safety glasses. If you are not qualified to work on electrical systems, hire a licensed electrician. Electrical work can be dangerous, and it is important to take all necessary precautions to prevent accidents. The NEC is a comprehensive set of rules that governs the installation and maintenance of electrical systems. The NEC is updated every 3 years to reflect changes in technology and safety practices. It is important to stay up to date on the latest NEC requirements to ensure that electrical systems are installed and maintained safely. The NEC is enforced by local electrical inspectors. Electrical inspectors review electrical plans and inspect electrical installations to ensure that they comply with the NEC. The NEC is an essential tool for ensuring electrical safety. By following the NEC requirements, we can help to prevent electrical accidents and protect people from electric shock. Remember to always consult the latest edition of the NEC and local amendments for specific requirements in your area. Different jurisdictions may have local amendments to the NEC, which are additional requirements that are specific to that jurisdiction. It is important to be aware of any local amendments that apply to your project. Local amendments can be found in the local building codes or by contacting the local electrical inspector. The electrical inspector is responsible for enforcing the NEC and local amendments. The electrical inspector can provide guidance on how to comply with the electrical codes. The electrical inspector can also conduct inspections to ensure that electrical installations are in compliance with the codes. Consulting with the electrical inspector early in the project can help to avoid costly errors and delays. The electrical inspector can review the electrical plans and provide feedback on the design. The electrical inspector can also inspect the electrical installation at various stages of the project to ensure that it is in compliance with the codes. Working with the electrical inspector can help to ensure that the electrical system is safe and reliable. In addition to the NEC, there are other standards and codes that may apply to electrical installations. These standards and codes may address specific types of equipment or installations. For example, there are standards for the installation of fire alarm systems, emergency lighting systems, and renewable energy systems. It is important to be aware of any other standards and codes that may apply to your project. The standards and codes can be found in the local building codes or by contacting the local authorities. Compliance with all applicable standards and codes is essential for ensuring the safety and reliability of electrical systems. Electrical safety is a shared responsibility. Electrical contractors, engineers, inspectors, and homeowners all have a role to play in ensuring that electrical systems are safe. By following the NEC, local amendments, and other applicable standards and codes, we can help to prevent electrical accidents and protect people from electric shock. It is important to remember that electrical work can be dangerous. If you are not qualified to work on electrical systems, hire a licensed electrician. A licensed electrician has the training and experience to safely install and maintain electrical systems. A licensed electrician can also ensure that the electrical system is in compliance with all applicable codes and standards. Hiring a licensed electrician is an investment in your safety and the safety of your property. Remember safety first and always consult with a professional.